All right, here we go. All right, so anyway, sorry, I know where you were, so. Thank you. Okay. All right, you guys seem kind of quiet today, all right? Everybody right?
Yeah.
All right.
How was your
Anyway,
weekend?
it was pretty good. It was cold, but I went outside both days and went 2 different hikes, real short hikes, but that Green Trail, you ever been on that one?
Oh, yeah.
And so a couple of that.
Was it good?
Yeah, it was pretty good. Just a trail, but in the winter, the good thing about the winter, you can actually see the water. You can see all the way through the trees. So you get to see it a lot like that. So anyway, you're gonna have a nice week. After today, it's gonna be very nice today. This whole week. So all right, let's watch our timing a little bit. Here's what's happening. This week and next week will be mainly you doing the labs, lab quiz, doing the labs, and then you'll have to sit with your group and answer questions about the labs. And then I will review the labs, because if you discover everything you're supposed to discover, then my review will say, you'll just sit on your head, will go like this. Oh yeah, I knew that. I knew that was single replacement. Oh yeah, I knew that was redox. And anyway, I'll review one whole day, and then we'll have a lab test next week, probably on Wednesday. It looks like maybe Wednesday. And then that will be it. Then Thursday, we have it come Thursday, but we don't go to school on Friday and or Monday of the following week. So you have all this week, you have 4 days next week, and you have 4 days the week after that.
And then what's after that?
Then we get into like 3 chapters in a row where we're mathematical. We use the mole concept. It gets into a lot of numbers. And so some of you will actually like that. You'll actually like the mathematics of chemistry quite a bit. So, and then that also leads into a couple of labs also. So we'll do that. All right. All right, so you seem kind of quiet today, but let's see if I can get you lived up a little bit. If you, without looking, okay, without trying to look at any of your sheets, and I don't want you looking at it, I just want to see, without studying, how many of these would you know? So let's start with Zach. We'll go this way. Zach, ready? What would you call that right there?
That's a bottle.
Okay. That wouldn't do it tomorrow. I wouldn't give you credit for that. All right, this is a wash bottle.
Oh.
Okay. Number 2. All right, go ahead. I know you haven't studied. What? No? Okay. Okay, and I know you haven't studied. That's okay. We're just seeing how many you don't know already, all right? All right, this one, it holds a really expensive instrument called a burette. It's a burette clamp. All right, number 3. Not test tube holder. Actually, you'll see a test tube holder in a minute.
Test tube rack.
Yes. Okay. Number 4. Okay, that was good. Number 5. Very good. Number 6. Yeah. Learn how to spell that. Erlenmeyer flask. Okay. 7. We're just seeing how many you know without studying. Okay. It is a flask, but it only has one single line on it. It only measures one volume. So it's called a volumetric flask. Okay, this one. Okay, all right. This one has a real wide mouth, and it's called a gas collecting bottle. All right, how about this one?
That is a Bunsen burner.
Okay, that's right. And number 10.
Mortar and I forgot. Oh wait, mortar and I don't know.
Pestle. Mortar and pestle. Okay, this one here, number 11. Very good. Number 12.
Studied over the weekend.
Number 12.
Aren't those like beaker tongs or?
Well, there are beaker tongs, but this one is actually not wide enough for a beaker. So, but you get the tong part. Okay, these are crucible tongs. Okay. All right, number 20. 20. Wait, I mean 13. 13. Back up to you, Zach. Well, it's actually a test tube brush. It's not really made of wire. This part might be wire, but this is like a nylon. So test tube brush. How about this one? Yeah, not tweezers, but forceps. Okay. How about this one? Yeah, funnel. These are like the skinny straw-like things, but they're made out of glass. This one only has one line on it. Volumetric pipette. Okay, this one right here. This is actually a solid piece of glass here. All right, stirring rod. Okay, this one. Okay, this one. And 19. That is test tube holder. It is number 20. Okay, these are really small. They're micro pipettes. Micro pipettes. 21.
Oh, that's the shove. It's not the shovel, but I know what it does. Yeah. You go in. It does.
Okay, right.
It's scupula.
Scupula. Okay, here, 22.
I'm not sure.
Okay, that's a, see how it's flat-ended on here? Spatula.
Spatula.
Okay, 23.
We cook mini pancakes. Safety left.
Okay, 24.
I can't remember the name.
Well, that's interesting because you had,
Oh, it is.
Yeah, that's good. Right there.
You starting with a C.
yeah. Hey, can you guys stop?
Huh?
Stop.
That's Crucible.
Right, okay, 25, back up to Zach.
Dropper.
Okay, and 26. Okay, 26. And this is probably one of the most expensive pieces of equipment on here. It's a real long, it's like a long graduated cylinder. It's called a burette. How about 27 here? And this is also, has lots of little lines on it. This one now? It's one of the pipettes, and it's got lots of lines in it. So it's a graduated pipette. All right, 28. Ring stand, and we actually use the poles in the table. That's what we use for that. 29. Corks, and 30. Ring, okay, 31. Watch glass, shaped like a glass, an old-fashioned watch. 22. I mean, wait a minute. 32. Wait, how did I get off there? Yeah, 32. And this one can be used to clamp so many things. That's why it's called a utility clamp. Okay? How about this one, 33?
Iron triangle.
No.
Nope, that's from Davy Jones.
Stop.
Wait, stop.
It's the same thing that's inside of something else that you're talking about.
A pipe?
Yeah,
Pipe stem?
pipe stem triangle.
Okay, that's it. Pipe stem triangle. Okay, remember the story. 34, right here. Really? Really?
Test tube.
Yes. Really? Oh, come on. All right, 35. Okay, 36.
Test tube holder.
No. And this one, it's a well plate, and it takes the place of test tubes. You could do like 24 different experiments in here, a little microchemistry. And 37. Zach, you get another one.
Is that a wired god?
Okay. All right. Now, so here's what I would do. Okay, if you really wanted to, I'm not saying I would, but if you really wanted to, the video of Friday's lesson is on there. You can actually see all of them again on the camera, and or you could just and I don't want it to just be pure memorization, but I did want you to try to remember some of the stories. And so if you take a look here, just take a look and then say, which one of those did I already know? And I know you didn't study, but is that the idea tonight? Just I'm gonna study all 33 of them tonight? I didn't know 10 of them, or hey, I didn't know 30 of them. So anyway, that's the first thing to do tomorrow. Go ahead, put that up, okay? All right, everybody ready? Okay, so now what we're gonna do is, that's your job to be ready for that tomorrow, and you need to study that. And, okay, so now look over here. Go ahead and hand out, take one of those and pass the rest down. What we're gonna do is, the lab we do, this lab and the next lab we do a little bit different than in the past. We've been doing more observational, more classical chemistry type thing. This is more of a formal lab write-up. And so I'm going to show you how to do that. And then go ahead and the second sheet. There you go. And then, so tomorrow, after we take the quiz, all the lab will be set up. And what I'm going to do is I'm going to walk around each table, and you're going to write little notes on the lab sheet about what are the safety rules for that lab. And then you should have maybe about 15 minutes tomorrow to do the lab, and then you'll have all day on Wednesday, you'll have all day on Thursday, you'll have all day on Friday to get all those labs done. So, all right, we don't put the papers together. That slows things down a whole lot, okay?
No, put 'em like
Don't do that.
Different
do
angles.
that.
Just take one and pass it down, and then take the other one. All right, go ahead and you'll need to go ahead and get a piece of paper out, because what you're going to do is I'm going to show you how to start the formal lab write-up. Now, I know some of you actually like to type, and I'm not saying you can't type, but I do want to show you how to actually do the formal lab write-up.
I like Fiona's more.
All right. Now, the book, by the way, somebody else, no name. If you have a name on your calculator, I'll certainly give it back to you, but it was left here. I don't know which class left it, but, you know, I would put some kind of name on here. I don't see any markings or anything like that. So, all right. All right, well, first of all, what I want to do is on your, when you do a formal lab write-up, it's gonna be a little different so that it is formal. And so what will happen is you would always put the title of the lab. So you say, okay, but what's the title of the lab? And so you take a look at the lab, and it says types of chemical reactions. And that's the first thing you write, is the title of the lab. Again, if you're gonna handwrite this, you can go ahead and start now, but at least make little notes to yourself if you're gonna type it. But okay, then you also, on the date, I would wait on that because you'd like to put the date that you actually turned it in, okay? So we're going to wait on that, and you put the date. But don't forget to put the date, so you might want to put a little place that says date, like that. Okay, there you go. Now put your name over here on the right-hand side and what period this is. This is called C class. Now, what they did is, I really like the author of this lab book. We actually have about 10 copies of this book. When I first got here, we bought that many copies, and right now I just photocopy it from we did actually buy the book, so I have the right to photocopy that one. But what we're going to do is you'll write the objectives. So let's take a look, and so write the word objectives somewhere on your next paper, and you highlight or underline, or you want to make it look like you meant to make this look nice. And it says write out the objectives. So let's take a look. And what are the objectives of this lab? And number one objective is to observe a variety of chemical reactions. And you definitely will. You're going to see 7 different reactions, actually 8 altogether. Number 2, so you just write these down. 2, to interpret and explain observations with balanced chemical equations. You're really good at that, so that shouldn't be too hard. What you're going to do is try to interpret. What is it that I'm seeing? I'm at that table. What do I think's happening? And I'd be able to put that into a chemical equation. 3, to be able to classify each reaction as one of more of the 4 major types. As of right now, I don't really have a combustion reaction. That can also be a little dangerous. I could burn a piece of paper, but when you're talking about things like fuels, we won't be doing combustion. And number 4, to recognize redox reactions and be able to write half reactions, which is your favorite, I could tell from the last test. Actually, I think you'll find that even though you might have messed it up on the test, I think you can understand this. I know you can. And so I'll be helping you with that if you have a little trouble with half reactions like that. All right, what's the next thing? So let's go ahead. I'll wait a little bit until you guys are done. Go ahead and write your observations down. And you have them right here right here on this. So keep right down. See where it says observations. So this is actually made, the lab write-up came with this. So it actually follows step by step. And so the next thing you should see is objective. Yes?
Do we write this on a computer too?
What it?
Are we writing this on a computer too? Like,
If you feel like, hey, I can write this now and I'll have that part of the lab write-up done, then you could do that. If you later want to go home and say, well, I guess I just have to type this at home and I can do it just as fast, and that's okay. But make little notes to yourself of what you're doing here. So this one happened to have 4 objectives on this lab. It happened before. All right. Now this one, the next one, it says apparatus, and this is right here. I would actually do that later. As a matter of fact, I think for this experiment, what I would do is make just little sketches, just a little sketch, and I would actually wait. I'd actually wait till I was done. And then you could go back and we're getting ready to study, say, what did I do at lab number 1? And then make a little sketch. And then lab number 2, number 3, experiment number 4. So I would do that later. So we're gonna, we don't need to leave a space for apparatus. We're gonna do that maybe a separate page or something like that. Now this one, I don't know why, when I was younger, they would actually make me write out the procedure, and I thought that's really a waste of time. I don't see the purpose in you writing out the procedure, and neither does the author. What does it say? Okay, so what are you going to write here where it says procedure? You're just going to footnote it, aren't you? So the book it came from is called Essential Experiments for Chemistry, and let's see what page it's on. That was an example. So this one, the procedure starts on page 53. I know, here it is. 53 is where the procedure starts. 53, and it goes all the way to 55. So for this experiment, it's page 53 to 55, and all steps, to do all the steps. Okay.
It's the same book. Yeah.
What? Yeah, same book. Mhm. Okay.
That's all we write.
Is everybody, what now?
That's all we write for that procedure.
Right, and I don't know why, I still have people every year, there's always one person who writes out the whole procedure, and I thought, why do you do that? Yes,
For apparatus, do we leave a space or do we just do it later?
which one?
For apparatus?
I would do that later, because right now, you don't know what the apparatus is, you haven't even been, tomorrow, when you visit the lab, you'll be able to make a little sketch. Most of the time, an apparatus is something you actually build. Here, a little sketch is probably the only thing you're going to do. Okay, now the next part is called experimental results. Now, this is where you have to kind of really be careful. So if you look, wait a minute, by the way, I'm going to show you how it goes here. Tomorrow, when you get ready, and you and your partner, you're ready to start, you can actually start at table 1 or table 6. You can start wherever you want. But what you'll do is, you say, what do I do? Well, there's nothing here on procedure. So what do you do tomorrow? You go to this page here, and this would be the first thing you would do. It says here, and we always will wear goggles, okay? And what we're going to do is, here's reaction number 1. So if you happen to be at that table there, then there's your procedure for table number 1. If you're at table number 2, you'll do reaction number 2. Yes?
Wait, do we pick our partner?
I don't know yet. I haven't decided yet. Yes?
So, experimental results.
Oh, we're going to do that next. Okay, I just want to make sure that tomorrow, when you get here, you'll say, well, what am I supposed, how do I start? And it all depends on where you start. If you start at table number 3, then you would start there. So I can't have everybody start at table 1, can I? And there's no real order to it. All right, so now let's go to the next part. It says experimental results. Now this is where I don't want you, I know what the author is doing. The author wants you to make your own observation table. But don't make it like this. Now, the reason you don't want to make it like this is that if you make one like that, then how many observations are you going to squeeze in that little block? Like half of one? So I don't want to do that. So this is just an idea, okay? So here's what I would do. I would do something like this. I would have a separate piece of paper and it says reaction number 1. And then what you want to do is, here's what I'm looking for, and the bulk of your grade on this lab, most of the grade is based on your observations, okay? So you want to do a good job on that. And so what you might want to do is, you might want to say, before, and what does that mean? Before they start reacting, you want to look at it. Like, there's some copper over there, and I want you to look at the copper and make some observations about the copper before you start heating it. Then when you heat it, you'll see a change. If you don't look at the copper ahead of time, you won't know what changed. So you'll do before and then during. What happens during the reaction? And then after. Now, I don't know how much you're going to write, so don't squeeze it in here. Like you could have a whole page and just leave a space for before and during and after. And maybe you won't use the whole page, but you'll do something like that. The only thing I don't like about this is that I don't want them boxed like here. If you want to make boxes, make them big. Make them big boxes, I get it? So this thing here might be really, really big, and maybe the next one. So this is reaction number 1. It doesn't have to be in a box for me. So when I grade it, I'll look at your reaction 1, I'll look and say, ooh, that's a good observation, that's a good, ooh, that's not so good. And that's how I'm looking at your that part of the grade. All right, what's the next part of the lab? Now, again, that might take 2-3 pages of your lab report. So we don't need to write that yet. That's going to happen. So what's going to happen next? So what we're going to do is we're going to find that section, and here it is. We go over here. Now it says here, analysis of the results. And here is where you want to sit with your partners when you can do it during the reaction or after. You say, hey, let's talk about this. In reaction number 1, in which substance in the air did the copper react? And what you would do is simply you don't need to write the question out, but you can just write the answer here. And then number 2, you guys would write the answer to that one. Number 3, 4, 5, and 6. All right. Now, these are pretty straightforward questions. So you would just have a section called analysis of results. And then these are the harder ones. These, they say, if you think you learned something, can you apply it to something? So these are application questions. So these are a little bit harder. And so you and your partners need to do that. You'll probably I know you have a little bit of tomorrow, all day Wednesday, all day Thursday, all day Friday, and then Monday you'll have a chance to sit and finish all the write-up. You can talk to your partner, you answer the questions, you do the follow-up questions are next, and then they have a conclusion. Okay, so what do you have to do in your conclusion? It says for each of the 7 reactions, write a balanced equation and classify it, and then it says if the reaction was also redox, write the Leo and the Gur half reactions, or write not redox, that reaction. Okay, and the last thing here, it says an organized, well-presented lab report will be structured as above with all the headings and subheadings underlined. And again, you can underline them, you could highlight them, but it should look kind of nice when you turn it in. And this is a little bit more formal lab write-up. Okay. What I thought I would do is I do want to go over some of the safety rules, and so what I'm going to ask you to do is I'm going to ask you to tonight I would like you to go and, well, I guess you don't have to read this ahead of time because you're going to be studying for your quiz, aren't you? Okay. So what I'm going to do is I'm going to show you. I'd like you to write some safety rules here, and then we'll be done for today. So. I'm gonna. I have the equipment back here. I have everything set up. It took me about a little over 2 hours this morning to get all this stuff ready. And then the only thing I have to do is wait. I have to wait. I can't put it up. I can't set it up right now. All right, number 1. Number 1. Every single experiment, you have to have your goggles on. Okay, everybody got that? So if you get tired of wearing the goggles, you can come over to this section here and take your goggles off. But as long as you're in the lab section, you have to have your goggles on. By the way, this is a dangerous lab. There's some danger in this lab, but if we go with the safety rules, then I think we're gonna be all right. All right, here we go. Reaction number one, you're gonna be taking some pieces of copper, and I have cut these up, and they're just the pure copper, that's what they are. And of course, you don't wanna get poked with them, but that's easy. But you're going to look at them and make some really good observations. You might even see bend it, how easy it is to bend. And after I put it in the flame, is it still easy to bend? I don't know. Okay, so then it says you're going to adjust the burner. This burner is very hot. I think I showed you the other day, right? And so the burner is very hot, and do you remember how to light the burner?
Yes.
Okay, so you start this first, don't you? Right? And then you lay it to the side, and then you turn the gas on like that. Number one rule, write this down. Don't ever reach across that flame. You got that? Do not reach across that flame. So wear goggles, always. Do not reach across that flame. All right. Now we have these crucible tongs. And so what you do is, you certainly don't want to put a piece of copper in there with your fingers. It ducts heat really well, doesn't it? And so what you're gonna do is, you're gonna put it in the flame. Now, I don't know how you want to do this. So I want you guys to have a little bit of freedom here. You wanna hold it up here first, and then come down to the hot part. You wanna lay it sideways. And I want you to do, that's before, and then during, and then after. Now, a little thing here says, it says here that, I don't have 6 inch, that's too much waste. And then, make some observations. Now, what I'd like you to do is a couple of extra things on this lab. So number one, I have a beaker of water here too. So you could also do something where, after the metal is really, really hot, you could bring it out in the air and make your observations. You could then put it back in the flame, and then maybe plunge it in the water. You can do different things like that to see what happens. And there's one thing I do want everybody to do, and write this down here, say, do the match thing. Now, so what happened one year is, I didn't have these little fancy, I didn't have these, all right, these are a lot cheaper. And so we had matches, and I have a book of matches that'll be there. And so what happened is, a student, I love the fact that they thought this up on their own. They put a piece of metal in there and got real hot, and they wondered, is it hot enough to light a match on fire? What a great science thing. They lit it up, and they came over here, and they laid it right next to it, and what do you think happened?
Boom.
You think it was hot enough? Okay, now, next thing was where the magic came in for me, is for whatever reason, after it lit the match on fire, they put the copper back in the flame. And that's when something neat happens. So if you write a little thing, we're gonna do the match thing, and if you wanna write down, the match thing is, light the match on a hot piece of copper, and then put the copper back in the flame. Everybody got that? All right, I don't wanna give it away, because I'll hear some oohs and ahs, and that's that. All right, now, I've had this happen for about a year, but it talks about what you're supposed to do before, during, after, like that. And there you go, that's number one. Let's go number two. Number two is, we have this solution here, and this is called copper 2 sulfate aqueous. Everybody see that? This is aqueous, and this is a big bottle, but I'll have this little bottle, this little beaker here. And what we're gonna do is, we're gonna ask you to observe the nail, okay, and I got these nails here. And then, because these nails have been sitting around for many years, they might have a little bit of iron oxide, they might have a little bit of coating on it. So carefully, I don't want you to poke yourself, but carefully see if you can clean them up a little bit. So what you wanna do is, you wanna get them kinda a little bit shiny like that. Okay, then you're ready to start the experiment, and what we have is a little test tube, and it's a lot easier to pour this into a little test tube than that big bottle, so that's what that's about. Now, what's interesting about this one, and you can make a little note to yourself, is they ask you to put it in there, and let's say it's covered about to here in that liquid. Okay, so what's gonna happen is, when you put a blue liquid in there, something could be happening to the nail that you might not see it, because the blue acts like a filter. And there might be something going on that you can't see. So every once in a while, what you wanna do is, you wanna get that nail and take it out and take a look at it. See that? Now this one's kinda neat because, a lot of things will happen right away, but you also wanna come back and maybe after a few minutes, maybe after 10 minutes, you wanna pull it out. So I'd like you not to leave the nail like overnight in here, because it'll actually rust in here. Anyway, you take it out and you can make some observations about that. All right, so there's that one. That one is not super dangerous. The first one is because of the flame. The second one is kind of a quiet but a neat reaction. I really like that one. All right, number 3 is dangerous. So let's take a look. Number 3, the directions say, it says here, pour some solid copper tube of sulfate pentahydrate, and you don't know what that is, you've never heard of that before, into a test tube, and it says less than 1/3 full. And then it says ensure the test tube is heat resistant. So it's your job, it is your job always, that you look for Pyrex or Pymex. And if it doesn't say that, do not put that in a flame. So I have this copper 2 sulfate pentahydrate, got the scoop noodles ready. And so you're gonna fill it about, I don't know, maybe about 1/3 full, something like that. Got that? Now, when you're using the test tube holders, you wanna make sure they're the top, don't you? So the heat, you're gonna heat down here, aren't you? So the heat's down here. Now, when you do it, you wanna angle the test tube, but you wanna make sure it's not pointing at anybody's face. That's number 1 safety rule, is do not point the test tube at anybody, including yourself. And so when you do that, you've already checked for Pyrex, just kind of go like that, let it heat. If you wanna flip it over, make sure it don't point at anybody, you can do that. And then make a lot of observations, okay? Just make sure you don't point it at anybody right there. This is kind of a neat one, but this one, I make a little note to yourself, you have to do number 3 before you can do number 4. Those are the only 2 that you can't do randomly. You can't do number 4 until after you've done number 3. Okay, so number 3, it says here, place some solid copper tube pentahydrate, sulfate pentahydrate, and then it says using a clean test tube clamp, hold it away, you're gonna heat it. I'd like you to heat it until it does something. You don't have to cook it to death, okay? And so here, you'll see something happening. And it says, heat until no further change has occurred. Now what you have to do is, this test tube is gonna be incredibly hot, incredibly hot. So what you do is, you carry it over to the next table, and you let it sit here, and it may have to cool off for about 15 minutes. So you don't wanna do this experiment, at the very end of the period, because you have to wait. I think you could, if you remember the test tube there. Okay, so now let's pretend it's over here and you know it's cool. You know the test tube's cool, and you know that this water is cool. What does number 4 say? Number 4 says, allow the test tube and the contents, reaction 3, to cool. That's another thing, is hot glass looks just like cold glass. Don't touch that. If you touch it later, touch it real quickly, because it'll burn you. Allow it to cool, and then use the medicine dropper or the micropipette and add 2 to 3 drops. I think it usually takes more than 2 to 3 drops, so you might even add, you want to cross it out, put maybe 4 or 5 drops of water in there. I think it's much more than 2 to 3 drops. Okay, and then anyway, something's gonna happen there, and I want you to, even though the test tube's cool and the water's cool, I want you to, after you put the water in, I want you to touch the test tube carefully. Yeah, you'll see something will definitely happen, all right? Let's go to number 5. Let's go to number 5. Now this one, we have 2 solutions. Here they are. The most important here is don't contaminate. That's the main thing. So I'm gonna have this solution with its own beaker. It says calcium chloride aqueous. That's what that says, right? So this will be on one side of the table, and this will be on the other side of the table. This beaker should never come over to the other side of the table. This beaker stays here, this beaker stays here. The thing that we're doing this part of the experiment is contamination. They both look like water, don't they? So you have to make sure that stays over here. So what you're gonna do, it says, on number 5, it says about a quarter full of calcium chloride solution, and then the second tube with about a quarter of this right here. And then you put them together, and you make observations before, during, and after. And again, I've had people that get into these experiments, they do more than just do it. Some people say, well, I did that, I guess I'm done. That's not being very much of a scientist. So you might actually think about some other things you could do with that. All right, let's go to number 6. This one is dangerous. Number 6, you're gonna have some mossy sink, And just like I talked about aluminum foil, is simply aluminum, but it looks like a foil, that's what I call it. This is zinc, and it looks like a piece of moss. And that's what they call it, mossy zinc, and stuff like that. Now, I will change, I'm gonna change this a little bit. I think it says here, how many pieces do they say? 8 piece, well, whatever company they bought that from, that must have been a huge piece. I'm gonna change that to number 6 to, I would say, put about 4, probably about 4 or 5 pieces of zinc. Because they're definitely not, they're not big enough to only have one. So here's the danger. Let's talk about this one. That's the danger. We have, the zinc is not that dangerous, okay? And we have the test tubes, so they're gonna be in a test tube rack, you have a test tube holder. And then what you're gonna do is, this is the dangerous part. So this right here looks like water. It's actually called 2 molar hydrochloric acid. It's well labeled, and this little beaker says HCl, doesn't it? So we don't wanna pour out of this, we wanna pour from this on. So you pour a little bit here, you pour a little bit on the zinc. Now, you happen to know what happens if you put hydrochloric acid and zinc together? No, not a bomb, but we don't want bombs.
It evaporates.
We actually do have a little bomb, mini bomb on this one, but what do you think would happen? Zinc plus HCl, what do you think might happen? What kind of reaction?
Redox.
There is gonna be a gas, but what do you think, A plus BC?
It's A plus BC.
That's not so.
B.
What's A plus BC?
Single Weisman.
Okay, so what's gonna happen is the zinc is gonna kick out the hydrogen, and that's where the mini bomb's gonna come for. So now, so we have this test tube, and I put zinc in here, and I put some hydrochloric acid in here, some pretty concentrated hydrochloric acid. And what you're gonna see is immediately, you're gonna see lots and lots and lots of little bubbles. Those bubbles are gonna be hydrogen gas. Now, hydrogen is less dense than air. So if you just sit there, all your hydrogen is gonna go up in the air, it's gonna be gone. We don't want it to be gone, because we wanna test it. How do we test that that really is hydrogen gas? That's what you do here, watch carefully. If your thumbs aren't big enough, I have a cork for you, but we don't put anything tight, nothing's gonna be tight, okay? But what I do is, when I shake it, tell yourself, make a little note to yourself, let it sit, let it react for about 2 minutes. So you got the acid, you got the zinc, look at me, do not do this. Why not?
Oh. You can get on your finger and it can
Right, it's
burn
2
you.
molar hydrochloric acid, okay, so we can do this and not splash any acid on our thumb.
What do we know?
Now, it's been about 2 minutes, okay, so let's pretend. Right, good question. Now, because of safety rules, I'm gonna talk about that. What happens if you get anywhere on you, you wanna wash it off. Same thing with your hands. If you get it on your hands, you simply wash it off. That right there is if for somebody that actually is a serious problem. That's like pulling the fire alarm. Don't mess with that unless somebody's in serious, if you're on fire or you got acid everywhere on you, and I don't think that's gonna happen. You have the eye wash station if you had it just on your face, but that would be for a serious situation, okay? Here, watch this now. So I put my thumb on there because I'm gonna trap that hydrogen gas. Now we have these things called wood splints. Okay, now for over 200 years, chemists knew when they saw bubbles, how did they know those bubbles were hydrogen gas? And they did the following test. It's called a pop test. Now is that on, let me see what's written there. It says here, if the gas appears, test it to see if we can identify it. Now how do we test it? We're gonna do a pop test. Okay, now, let's write that word down there, pop test. So here's how you do it. It is a little tiny explosion. We're gonna explode the hydrogen gas. The hydrogen gas is so flammable, it will actually explode. So what's gonna happen is, you're gonna go like this, okay, after about 2 minutes, and then I'll have a candle lit, and then you'll put it here, you'll start this on fire. Okay, you get it going here. Don't panic, just sit there, and when you're ready, say 1, 2, 3. Some people wait, some people don't. You go like this, okay? So when you put this flame in there and the hydrogen gas in there, you'll get a little mini explosion, and it'll actually break the sound barrier. It'll go like that. Now, if you get one that loud, that means you have just the right mix. Hydrogen has to mix with oxygen before it can ignite. So if you put it in there too fast, you don't have any oxygen in there, so you'll get a poof. sometimes people get just the right mix, they're patient enough, they have enough hydrogen, enough oxygen, they weigh, they go, "Boom," like that. So if you get one like that loud,
What does it sound like?
Alright, anyway, everybody okay, the acid is dangerous, slowly the hydrogen. Let's go next one, last one. Number seven. Now, this one, kind of interesting. The most important thing about this one, again, is contamination. This is hydrogen peroxide, H2O2. And it wants to decompose. Matter of fact, even the company puts it in a brown bottle because even in direct sunlight, it might break down and decompose. But if you just put it in a test tube, it'll sit there and won't do anything. So what we're gonna do though is we're gonna use a catalyst. Our catalyst is this guy here. This has manganese dioxide, but it's also manganese peroxide. Anyway, tiny bit. Make a little note to yourself on number 7. You only need a tiny bit of manganese peroxide. Okay? So I have a little tiny spatula. You just need a tiny bit. Because a catalyst, after it does its thing, it'll do it again, 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 again. So you don't need to put a lot in there. Now, you can hold your thumb. One more time, almost done, 30 seconds. You can hold your thumb over there, but you'll see so much oxygen gas is gonna be produced. So much is that it'll probably push your thumb. And you'll feel it pushing out. Now in this case, we don't use a burning wood splint. We catch it on fire, and then you're gonna have to take your mask down for a minute. Then you gotta blow it out. This is called a glowing wood splint. This has been used for over 200 years. How do you test for oxygen gas? In this case, what you do is, it's not on fire, it's just a glowing ember. You stick it in there, it bursts back into flame, just like you saw in that video. And that's the test for oxygen gas. In both these cases, when you get done, like this right here, when you get done with that, I have a waste beaker. Now, we don't pour that stuff down the sink. Same thing here, we have a waste beaker there. All right, tonight, if you'll study for your lab quiz, I'll probably pick your partner for this, I think.
Yes.
Okay.
Would the acid like destroy the tubes and the thing? The tubes?
Well, if you put zinc and acid down there, what would happen is it would make hydrogen gas. Now, would that ever explode? If there's any kind of a spark, you could explode the plumbing. So that's why you wouldn't want to do that.
What's the most dangerous one?
I think anything with the burner, you're about 2,000 degrees, that probably has the most danger to it.
Yeah, like the Statue of Liberty started out as bronze.
Yeah, it did.
Yeah, you can spend like, and then you can steal it, spend $20.
Yeah, copper's expensive.
Steel is Statue of Liberty.
How much is this worth in copper a lot?
It didn't used to cost very much at all.
Pennies.
Everything costs more now, but,
Now you get the converter. Or, well, platinum.
that's why I actually cut them in little pieces. They wanted to put a big piece. That's too much.
Alright, thank you.
And you get it, now you just gotta feel kinda like converters, I mean.
We should know which lab tools like go together, right?
Yes, let's say I wanted you to heat some beaker of water. Think about how you put them together.
Okay, alright, thanks.